Howdy folks, Doc here with Last Best Tool. Well, I got another astronomy tool from Harbor Freight here. This is a Pittsburgh wrench that telescopes. That's why I call them astronomy tools. But we'll get to that in a sec. First, I thought I'd revisit this Icon magnetic mat. Lots of good comments, and some people took issue to maybe the way I was testing it or my expectations or obviously the price, whether or not lifting it by a wrench is really any measure of anything. It's whether the wrench stays on it. I agree, but I thought maybe what I would do is replicate the pictures and see what happens. Now this one certainly could be on a flat surface, and of course any mat will hold anything on a flat surface, but it is helpful, it keeps it from maybe rolling away. But this one is definitely on a vertical surface. And you can see the drawer here. It's obviously some tool cabinet. So this is vertical. And I can see exactly what those tools are. So what I'm going to do is replicate this. I'm going to start out here just for fun. This won't take long. So if I hold this up, and now, you could argue maybe it should be on a toolbox or something, but I don't think it's going to make much difference. We can start out with this Icon plier. So you can see logo up. We'll replicate it its location right there above the Icon tag. So I'm going to put it right here. Okay, am I asking too much? Oh well. That socket, there is no way that socket is going to stay, simply because putting a socket, let me pull one off of this ratchet here. No way that would stay on. There's nothing you can do, except there is a trick I discovered. Maybe I'll remember to tell you that I was able to get it to stick doing something really specific. Let's see, what about a pair of slip joints up near the top? Here's the Icon slip joints pointed this direction, about in that position. Look at that, they stay there. What if nope. As long as I get them right on, there's a more powerful magnet right there, but do I have to be careful if I put a socket on here? Interesting. Anyway, so that one I can get right there. Here, nope, not over there, not over there, not over there, but if I get it right here, get it to stay. All right, and then a ratchet. I don't have that specific ratchet. I can use a snap-on ratchet because it's all chrome. Let me grab that here, and not that one. Here we go. So here's the snap-on ratchet. I don't have a socket on it, but I don't know, is that going to make it better? Well, let's go ahead and put a socket on it and see. Does that help? And take a close look at the positioning of it right there. Right there. Helps a little. But that's oh well. But let's go ahead and try the real test, which is going to be here. So we've got some slip joints, a wrench. What do we have there? It's 9/16. Set of side cutters, 7/16 half, and then this ratchet. And this is the closest I've got to it, this Icon here. That just might be the old, I don't think that's a 1/4 inch. Can't tell, I don't think it's a flex head, but I have a 1/2 inch, a 3/8 flex head. But we'll go ahead and try it and see what happens. So here it is. Go ahead, let's see, I'll line this up right here. That one stays there. Good job. What about the wrench? Was that the 9/16? It's over here. That, of course, stays. What about the side cutters? Let's see. They're kind of in the center, a little more to the right. Yeah, as long as that wrench is there. Can they survive on their own? Whoops. Yep, there they, whoop, bumped this thing. Gotta get it just right. Somewhere in there. There we go. Close. As long as it's perfect. And then I've got the ratchet. Let's go ahead and try that. So I will grab, let's see, this one here, put a socket on it. Okay, now here's what we're doing. It's on this side, here's the logo, so we are going to run it right up against that. And I'm wondering, does it have to have that other socket there in that position? We'll find out. So here is the ratchet in that corner. Can't get that to stay. What about if I put that other socket? Looks like it's right about, that's almost the top, right about there. So this is what it'd be, right there. That's what I'm replicating. And there it is on the package. See, and now if there's nothing below it, what happens? The socket might stay on, but the ratchet and socket mechanism here. Ready? Oh well. Anyway, so make that what you will. Let's get back to this Pittsburgh telescoping tool. Now, Pittsburgh telescopes things. In fact, Quinn also has some telescopes. And I noticed the Pittsburgh, they've got a telescoping quarter-inch drive handle, quarter-inch square drive handle. They've got a telescoping 3/8 quarter-inch ratchet. They've got a big telescoping half-inch ratchet. And they've got this. Now, they don't call it telescoping. They call it extending or extension. So if you're looking it up, that's where you'll find some of these. What do I think? Well, it's typical Pittsburgh kind of quality on the front end. There's some sharp edges. This does seem fairly solid. But my question is, okay, I get it. I'm always into novel tools. Actually, I have two questions. The first is, why? What do you do with this? And I think it has some benefits. And I think it might be good to produce a high quality one. Maybe even a smaller one. I don't know, at this size. What about, what would be a normal 8-inch? Because what we've got here, well, this is a 15-inch here. And I think this is a 12-inch. So this is, if you look at this, about 12 inches on the small side. And a little over 15 on the big side. So it does answer that question. And you're not supposed to put a huge amount of force on these things. So that's probably okay, this mechanism here. And then it's just if it snugs up. But none of these are, hugely precise. So it's not that, there are a lot of tools that I might be a little bit more skeptical with Pittsburgh. But unless the metal breaks, the design's pretty dialed in. It does have a fairly good knurled coil here with minimum three contact points, 4 when it's lined up maybe. Or is it? What do we got inside there? Yeah, you could get 4. This the standard kind of telescoping mechanism. It does have some stopping points should you want that. And I've used that with that same mechanism with their ratchet. It's held up, and of course lifetime warranty. But is there a specific use? And I was trying to think, well, what does this allow you to do? Can you get in somewhere and then telescope it for the leverage? Would that be good? Or is it portability, say in a car kit? Because we'd all like to have a giant, adjustable wrench, because remember, they go down to 0. So it's 0 to 1.5 inches, I believe, on this thing. Right there, almost. Where is that? Yeah, almost 1.5. So that's a pretty good range. So, a lot of stuff can be fixed with an adjustable wrench, and then having one that, has this magical ability, that could be good. Let me know. I'm going to play around with it and see where that might really fit in, because I like the idea of making things telescope as long as it's a good enough mechanism to hold together. But my second question, and that is, what should Harbor Freight or Pittsburgh telescope next? They've gone after the ratchets and this. What else is there? Because we could telescope a lot of things, almost anything with a handle. I had some trimmers for, large landscaping trimmers that had telescoping handles. You'd unscrew it and slide them out so you could, get it a longer reach, but then also shorter for that. But what else could you telescope, or what should they telescope? Maybe Harbor Freight will watch this and say, hey, that's a great idea. And I noticed Quinn's got some telescoping stuff too, so maybe they'll move up the line. If these telescoping things pan out. Maybe Pittsburgh is kind of the experiment, see what happens, see if people like it, do they buy it, do they use it. But with this thing, look at how rough that is up here. But anyway, maybe they'll do some more. So what should they do? Let me know. And with that, Doc out.